Sinusoidal functions. A sinusoidal function is something that repeats a pattern. That's the idea. That's something that repeats. Now, a sine is a sinusoidal function, but it's not the only one. There's many different ones we can talk about. For instance, it does have a wave pattern to it. Okay. Now, there's periodic functions. A periodic function could be written as something like this. Okay. Because it's repeating the period roughly. I know it's not perfectly to scale, but it's repeating a pattern. A sinusoidal function will do it in a wave type pattern. Okay? And then a sine function has a specific wave to it. And I think we talked about this before. One of the ways we can find out these values is plugging in our x values, because we're in degrees, into a calculator and figuring out what the y values will be. So just as a side note, we're going to quickly create a sine wave here. So 0 sine is 0. The first one I have here is a value of 90. So 90 sine is 1. And are you aware of this? Yeah?
Yep.
Okay. Do you know what 180 will be?
0.
Yeah, 270.
Negative 1.
Good. 360.
0.
Okay. And that's a period in the function right there. So a period talks about how long it takes to get back to where we started. Okay. So I'll highlight that in black, and then the rest of it we'll do in red so that you can see that this function continues. Going the other way, we have negative 90, 0, and then back down. So this is a wave pattern, which makes it sinusoidal, makes a wave pattern. This is considered the period of the function, okay? From here to here is the period. And the period actually took from 0 to 360. So in this case, and we're graphing this one right now, it takes 360 degrees to go through a period of the function. And to be a period of the function, we have to get back to the same spot, but be approaching it in the same manner. So for instance, at 0, we go up, and we actually hit 0 again at 180. But before, if we look, we were coming up at it. And at 180, we were actually heading in a downward motion. So that's not considered a full period. The full period is when we're approaching that point at the same, point in the same fashion. So another good way to measure it could be, for instance, maybe starting at negative 270, and when do we get to the value of 1 again? Well, we get to it at 90. Well, the difference between these two, if I subtract it, is still 360 degrees. So no matter where we move in this wave, a period is 360 degrees. Okay? There's a couple other things they're going to talk to you about. Amplitude is one of them. Have you guys talked about that? Amplitude. Now, amplitude has to do with, let's get some dotted lines across here. How high, so our peaks and our troughs. So essentially, first of all, we have a max value, and our max value here is 1, right? It actually hits the max every 360 degrees, we get to that value. And our minimum value is negative 1, right? The amplitude is essentially half of the range. So this would be the range. The range is from the max to our minimum value. So the entire range of this, and we could figure this out, our range, we can take these values, and if we subtract the two, so our max value being 1, and we subtract our min value, so max subtract min, okay, which is negative 1, will give us a range of the value of 2, okay? Our amplitude, and we'll move this down so we can get another function here. Our amplitude is essentially half of that, okay? So we're taking our max, subtract our min, and then we're dividing that value by 2. And that'll tell us the amplitude of this. And we'll talk about the amplitude of it and how it can be related to other things. So in this case, we're talking about 1, subtract negative 1, divided by 2, which will be 2 divided by 2. So our amplitude in this case is 1. Okay? And they measure amplitude from something called the equation of the axis, which I guess I could have talked about earlier. The equation of the axis is kind of the line that runs through the middle of this. So the middle of this is essentially at the value of 0. Okay? The equation of the axis can be found by getting a formula very similar to amplitude. I'm going to call it the E. Well, first we'll give it a whole name. Equation of the axis. Okay, and that's this guy right here. That's that line going through the middle. And we'll call it the EOA. Okay, equation of axis. And that's equal to the max plus the min divided by 2. Okay, so in our case, that's 1 plus -1 divided by 2. That'll give us a value of 0, right? And that's exactly where ours is. It's on the y value of 0, our equation of the axis. The amplitude, like we talked about, the amplitude deals with the range from the equation of the axis to the highest point, or from the equation of the axis to the lowest point. In other words, that's a value of 1. It's 1 away from both of those. Okay, so that's what the amplitude's talking about in this way. So we have the equation of the axis, we have the entire range, the amplitude, the period. I'm going to quickly take a look here. Period function. I think that's all. Equation of the axis, amplitude. Yeah, those are all the